So these are coming from the textbook on page, let's see, do I have it open here? So on page 429, and I thought I'd walk you through these odd exercises. So when I see angles like pi over 4, 4 pi over 3, um, those are nice unit circle numbers. So all we're really going to look at is a unit circle to do some of these. So but your also thing you got to remember is that the x, because the x, I mean, we did this in past work, so the x and y for each of these points correspond to the cosine of the angle and the sine of the angle. Okay, so this question here says, hey, what's the cosine of pi over 4? So if I go to pi over 4, and we know the cosine of the x, so that's going to be equal to root 2 over 2. Then it asks me to find the arc sine of that answer. So what angle has an arc sine, or what angle has a sine of square root of 2 over 2? Now, you're going to see in this unit circle, now sine is y, right? So you're going to see that answer there, and you're going to see that answer there. But what you got to remember about the arc sine function is they limit the output, the range from negative pi over 2 to positive pi over 2, because otherwise it's not a function. Because the sine function is not one-to-one, right? It has all these dips and curves, not one-to-one. So we limit it just to one cycle from negative from negative pi over 2 to positive pi over 2. That way, this part is a function. That's one-to-one in that part, right? That's why that happens. I talked about this in another video earlier, so I won't belabor the point here. So, what angle on this interval, or this domain, has a sine of square root of 2 over 2? Well, you're going to see for pi over 4, 45 degrees, it's exactly the same, because the x and the y are the same. So the answer to this one is also pi over 4. So it looks like it's the same answer. They undo each other. Okay, let me clean this up. So number 21 says, so first off, we're going to find the cosine of 4 pi over 3. So I'm going to go find, because that's a unit circle number, let's go find the 4 pi over 3 angle. And we're looking for the cosine, right? So the cosine is the x value. So 4 pi over 3 is right there. So that's equal to negative 1/2. So then we're going to ask ourselves, now they're looking for the arc sine. Why did I write it that way? Oh my goodness. So the arc sine of negative 1/2. Well, remember, we're going to only look at this interval here from negative pi over 2 to positive pi over 2. And so I'm looking, when is the y value equal to negative 1/2? And I'm seeing that right there. So the answer is going to be, now we don't want to use 11 pi over 6. We got to go, remember, we're going from negative pi over 2 to positive pi over 2. So that's going to be, well, I see the reference angle is pi over 6. So that's going to be equal to negative pi over 6. And that's what they're looking for here, and that's what my math will be looking for. Okay? So for number 23, that's not a nice unit circle question. And they're asking me to find the arc sine of that angle first. So this is telling me some angle, I don't know what the angle is, has a sine that's equal to 3 over 7. That's how you can rewrite that arc sine. So not a nice number. I don't want to have to deal with this too much. So what I'm going to do is, we know that this is y, and this is the radius, or that's the opposite, and that's the hypotenuse. So 3, 7, and then it's a right triangle, so we can use the Pythagorean theorem. So 49 minus 9 is the square root of 40, and I guess if we want to simplify that a little bit, we can think about it as 2 square roots of 10, right? So, I mean, that's 4 times 10, and we take the square roots of them, so that's 2 square roots of 10. And so let me come up here and erase that. It won't let me erase it. Okay. So we'll just think about this as being 2 square roots of 10 here. I'll leave it right there. So now they're saying find the cosine of that angle. Well, here's the angle. right? We said, because there's the opposite, there's the hypotenuse. So the cosine of that will be the adjacent side, or x, over the hypotenuse, or the radius. So that would be the cosine of that angle. Okay, and this is where we're going to go next with this, with the next, for 27, 29. So now for 25, they're telling me some angle has a tangent that's equal to 4, or 4 over 1. And remember that tangent is opposite over adjacent, or y over x when you're thinking about it on being on a unit circle. So let's draw a little angle, little triangle. This is theta. So y is 4, adjacent's 1. So now we're going to square those. So I think that's the square root of 17. It's at 4 squared plus 1 squared. And now they're asking me to find the cosine of that angle. I'm sorry, they're asking me to find the cosine of that angle. I was right. So cosine is the adjacent over the hypotenuse. And there's nothing wrong with that answer. 1 x over r, or adjacent over hypotenuse. If you wanted to, you could rationalize it. Rationalization of radicals is kind of, it's not as big a deal as it used to be. So root 17 times 1 over 17 would be the spiffy answer for that. Okay, so now let's go on where we're going to have an expression rather than a numeric answer. So for number 27, I've got some angle, and it says I know the cosine of that angle is equal to x over 5. Well, I'm not going to be able to do too much with that like I was doing, but let's draw a triangle. Here's the angle. And we know this is the adjacent side, that's the hypotenuse, or x over the radius. So this is x, this is 5, and because this is a right triangle, we can find that other side. So isn't that 25, 5 squared minus x squared? And then now they're asking us to find the sine of that. So that's going to be the square root of 25 minus x squared over 5, and we're done. Now, they're telling us this because they aren't worried about negative angles or negative expressions. Same deal here with this one. We've got some angle has a tangent here. Just a minute. Some angle has a tangent that's equal to 3x, or 3x over 1. So let's draw that triangle again. Here's the angle, so opposite over adjacent. So the hypotenuse will be 1 squared plus 9x squared. And then we take the square root. Remember, we're doing 1 squared plus 3x squared, and then taking the square root. So that's where I'm getting the 9x squared from. Now they're asking me to find the sine of this angle. So the opposite side is 3x. The hypotenuse is square root of 1 plus 9x squared. There's nothing wrong with leaving that in this form. If you want to rationalize it, you certainly can. 3x times the square root of 1 plus 9x squared over the square root of 1 plus 9x squared. Okay, good answer, more exact answer, but it looks a lot more confusing to me. Okay, so I hope that helps answer your question about what you put in. I'm going to ask you a question like this on the next exam, in fact, in the next quiz even. And one thing to pay attention to is one like number 21, where they don't just cancel each other. If I had asked you arc sine of sine of 4 pi over 3, it won't just cancel each other out, because the output for arc sine, right, is between negative pi over 2. Well, let me do that. Let me actually work this through this, because that's what I'm going to ask you. So I've got to figure out, well, I guess I can use the unit circle. Why don't I use the unit circle? I erased it, but that's okay. 4 pi over 3 is down here. I know the reference angle is pi over 3, or 60 degrees. So that means this side is, because I'm on the unit circle, this is the square root of 3 over 2, and that's going to be negative, and this will be negative 1/2, and this will be 1. You could also draw it this way, the square root of 3, 1 and 2, and get the same result. And of course, that's negative, that's negative. So now they're asking me to find the arc sine of that. So I know, first off, I know the sine. What's the sine of the square root of 4 pi over 3? Well, if you had a unit circle, you would see that The coordinates on that point is negative 1/2, negative root 3 over 2. So the sine of that angle, so the sine of 4 pi over 3 is equal to negative square root of 3 over 2. And then you got to worry about the output for the arc sine. So they don't just cancel each other out. And we're going to ask ourselves, so on this part of the unit circle, when is the sine equal to negative root 3 over 2? And that's, of course, being a negative angle, will have to be like this. And that's the sine. Let's see, what was they asking? Let me go up and look at the problem. Sine, arcsine, right? So I'm going on sine. So here's that is, and I've got to worry about, this is going to be negative square root of 3 over 2. So that's going to be a pi over, same reference angle, pi over 3. So that's going to be the answer, because except this is a negative angle. So the way we answer that, it would write negative pi over 3 rather than 4 pi over 3. Okay, it's the same. It's an angle that has the same sign. Is basically what you're doing. All right, so hopefully that helps.